Hi everyone. This is still log page 3 on the transformations of functions. This is day 2 and our objective for this particular day is using stretches and compressions to sketch graphs of functions. The first thing I want to talk to you about is a rigid transformation. A rigid transformation is when the basic shape of the graph is not changed. In other words, it doesn't get bigger or smaller. The shape remains the same. Horizontal shifts, when we shift something left or right, vertical shifts, when we shift something up or down, and reflections are all rigid transformations. These transformations do not change the shape of the graph. They only change the position of the graph, where it's located and how it's oriented. Okay, an example would be shifting up 2 units. That's a rigid transformation. Like the problem that we did yesterday, h of x equals x squared plus 2. If it's outside the function, like we talked about in the previous PowerPoint, it's a vertical shift. Since this is plus 2, it's going to be a vertical shift up 2 units. This is an example of a rigid transformation. Non-rigid transformations are what we're going to look at in this PowerPoint. A non-rigid transformation will cause a distortion or a change in the shape of the original graph. A vertical stretch or a vertical compression, a horizontal stretch or a horizontal compression will all change the shape of the graph. These are non-rigid transformations. A non-rigid transformation of the graph of y equals f of x is represented by g of x equals some number c times f of x. This transformation is a vertical stretch if c is a number greater than 1. It is a vertical compression if c is a number between 0 and 1. The numbers between 0 and 1 are all proper fractions, like 1/2, 2/3, 3/4. Also decimals between 0 and 1, like 0.125. Okay, these are all numbers between 0 and 1, which will cause this transformation to be a vertical compression. Let me back up just one time here. A vertical stretch is going to make your graph more narrow. A vertical compression is going to make your graph wider. Okay, another non-rigid transformation of the graph of y equals f of x is represented by g of x equals f of c of x, where the number c is being multiplied on the inside of the function. This transformation is going to be a horizontal compression. We're going to press from the side if c is greater than 1. It's going to be a horizontal stretch if c is a proper fraction between 0 and 1 or a decimal between 0 and 1, a horizontal stretch. The horizontal compression is going to make your graph more narrow. The horizontal stretch is going to make your graph wider. So let's look at some examples here. Compare the graph of each function with the graph of f of x equals the absolute value of x. H of x equals 3 times the absolute value of x. Here we have the parent function, which is the red graph. This is the absolute value of x. When we change the y coordinates by a factor of 3, then what happens is this graph stretches upward. You take the ends of this graph and stretch them up so that the graph becomes more narrow. If you can look at these points 0, 0, and then you also have the point 1, 1, But if we're changing the y coordinate, we're multiplying the y coordinate by 3, then this point is going to be 1, 3. Negative 1, 1 becomes negative 1, 3. So here the y coordinates are being multiplied by 3. We're multiplying this time, which is what causes this to be a vertical stretch. Okay, so let's look at this one more time. This is relative to the graph of f of x equals the absolute value of x. The graph of h of x equals 3 times the absolute value of x is the same as 3 times the function. So this works with any of the library functions. And this is a vertical stretch of the graph of f, in this case the absolute value. Each output, or y, is multiplied by 3. Okay? Oh, these have not been animated right there. My fault. Let's compare the graph of each function with the graph of f of x equals the absolute value of x again. G of x equals 1/3 times the absolute value of x. Okay? Here, the red function is our parent function. That's the absolute value of x. And what happened when I multiplied by a number that was between 0 and 1? The graph got wider. So it's like we pushed down on these sides. This is a compression. And in this case, every single one of the y values is going to be multiplied by 1/3. So this is relative to the graph of f of x equals the absolute value of x. And this is a vertical compression. Each output, or y, is multiplied by 1/3. So right here, 0, 0. Right here, 1, 1 becomes 1, 1/3. Negative 1, 1 becomes negative 1, 1/3. Okay, let's look at this one. G of x equals the absolute value of 3x. Okay, again, we're graphing the red function, which is the absolute value of x. And this solution says that we have here, because we are inside, this is going to be horizontal. Since this is a number bigger than 1, this is going to be a horizontal compression. Each x value here, because it's horizontal, each x value is multiplied by, oh wait, why is this 1/3? Because we're inside the function and it's going to do differently than what we think. So we are not multiplying by 3, we are multiplying by the reciprocal of 3, which is 1/3. So every x value, here's 1, 1. The 1, which is the x, is going to be multiplied by 1/3. So now it's going to be 1/3, 1. Okay? So 1/3, 1. When this is g of x equals 1/3, then notice what happens here. The absolute value in red gets wider. So this one is a horizontal stretch. We're taking these from the side and we are pulling out to stretch it horizontally. This is a horizontal stretch. So each x value is multiplied by 3. So this is a horizontal stretch by a factor of 3. Okay? Now, you should try these on your own and see what you can do with them. Pause this video and try these. See what you can do. Okay, here's the first one. H of x equals 4x to the third. The 4 is outside the function. Since it's multiplying on the outside, it's a vertical change. Since 4 is greater than 1, it's a stretch by a factor of 4 because outside the number does not change. The output, or y, is multiplied by a factor of 4. G of x equals 1/2 x, that quantity squared. 1/2 is on the inside of the function, so this is horizontal. It's a stretch because 1/2 is a number between 0 and 1. So this is a horizontal stretch by a factor of 2. The input, or the x, is multiplied by a factor of 2. P of x equals 1/3 times the square root of x. The 1/3 is on the outside of the function. So since it's outside, it's vertical. Since 1/3 is between 0 and 1, it's a compression. And it's a compression by a factor of the number because it's outside 1/3. The y value is multiplied by 1/3. R of x equals the square root of 3x, the argument 3x. The 3 is on the inside of the function. Since it's inside, it's a horizontal change. Since 3 is greater than 1, it's a compression. And since it's inside, we have to multiply the x by the reciprocal, which is 1/3.